Hello everyone, once again. So this is the lecture number 4th of the current electricity for boats. Okay. So in the last lecture we discussed about what is battery, correct? Okay. So now in this lecture we are starting with a very new concept which is known as what? Kirchhoff's rule. Okay. So Kirchhoff's rule, it has two rules. First rule is known as junction rule. Very easy to understand. Please do not read over here. Firstly, let's understand. What do we mean by junction rule? Very simple. Whatever current is coming to this junction, it will go away. Okay. So it means I1 plus I2, it should be equal to I3 plus I4 plus I5. Simple. Okay. Now at any junction, the sum of current entering the junction is equals to the sum of current leaving the junction. Simple. Whatever current is coming, the same current will move away. Or in simple words, we are trying to say that none of the current or charge can stay over here. Accumulation of charge is not allowed when the current is flowing at steady rate. It means what? When current is flowing at the what? At constant rate. Are you getting it? Right? So it is same thing as equation of continuity. Whatever current is coming, right, or whatever mass per second was coming, the mass per second was going out. Same thing as we play with water, correct? Okay. So whatever is coming from the tap, from the pipe, it should move away, correct? Okay. So okay. Okay. So junction rule says this, that when current is steady, okay, then there is no accumulation of charge at junction. Okay. So it is same as fluids as equation of continuity. Are we getting it? Correct? Let's discuss more. In over there, in equation of continuity, we used to write m1 dot equals to m2 dot. It means what? Mass coming per second equals to mass going, mass coming per sec equals to mass out per sec. Over here we should use mass or charge. Over here we should use mass or charge. Your call. Yes. Over here we should use what? Charge. So we can say Q1 dot equals to Q2 dot, or I1 equals to I2. If only one current is, I1 is coming and I2 is moving away. Or over here we can also write Q1 dot plus Q2 dot equals to Q3 dot plus Q4 dot plus Q5 dot. What do you understand by Q dot? It means charge upon time. What is that thing? Yes, you are all correct. That is nothing but current. I1 plus I2 equals to I3 plus I4 plus I5. Okay. So if they are asking on what principle this rule is based on, so you should answer if this is based on what? That no charge can accumulate at junction. Okay. Simply. Okay. Whatever current is coming, it should go away. Okay. And the charge accumulation is strictly prohibited. Okay. Now, okay. Second rule of Kirchhoff is known as what? Loop law. Okay. These all rules, they are very important. Okay. Second rule over here is known as what? Loop law. Okay. So the loop law says that if you are completing one cycle, you are completing one cycle like this. Okay. If you are completing one cycle like this, the entire algebraic sum, if you are starting from same point, you are ending to the same point. The algebraic sum of the entire potential, it should be 0. Are you getting it? Okay. So let's do it and let's find it out whether this is coming or not. Okay. So we are starting with A. VA. Okay. We are starting with A. Let's say potential at this point is V. Okay. Chalega. Now as we are jumping from here to here, let's use some other color. Okay, let's say we are jumping from VA, like from this point to this point. So potential will increase or decrease. Let's say over here the potential of the battery is V, guys. So the potential will increase or decrease? It will increase. Yes or no? Correct? Okay. Now, when we are moving through this line, R4, so potential should increase or decrease? It should decrease. By how much factor? Minus I. Resistance is R4. Okay. Now, when we are moving through R1, so the potential should decrease by a factor of IR. So negative IR. Over here, when we are jumping from, I hope you are getting it. Okay. When we are jumping from here to here, R2, so it will become negative IR. Are we getting it? Right? Okay. Now, when we are jumping from here to here, okay, R3 to point A, so we should write negative I R3. Are you getting it? When we are jumping from one more time, okay? If you want to get it, let's do it one more time. चलो एक बार, ठीक? एक बार फिर से देख, from here potential will increase. So initially potential was VA of this point. Now it will increase by V. When we are jumping from here to here, potential will decrease by I R4 minus I R4. Okay. Now when we are jumping from here to here, potential will again decrease minus I R1. When we are jumping from here to here, potential will again decrease by negative I R2. Now when we are jumping from R3 to again A, so negative I R3. Now when we are reaching to this point again, obviously we will say, okay, V. Now you are coming again to potential A. Yes or no? You are coming to point A. That's why you are coming again to potential A. Yes or no? So now from here, VA will get cancelled out. Correct? So that's what he's trying to say. When you are doing the entire loop thing, see, final answer is this: V minus I R4, V minus I R4 minus I R1 minus I R2 minus I R3 equals to 0. This is what he's trying to say. When you do the entire loop, the algebraic sum V minus I R4 minus I R1 minus I R2 minus I R3 equals to 0. The algebraic sum will become 0. Okay? The algebraic sum of changes in the potential around any closed loop involving resistors and cells in the loop is 0. I hope you are getting it. Okay? So this is known as loop. Okay? So again revising it one more time. What was our Kirchhoff's rule? Under Kirchhoff's rule comes two laws. First is what? Your junction rule. So junction rule says that none of the charge can accumulate at the junction. So the current, whatever incoming current is equals to outgoing current. Okay? When it will be asked in both, so please write in this civilized way. Okay. Now, when we are talking about loop rule, right? So when we are starting from some point, if we are coming to the same point again, the potential difference should be 0. Okay? For the entire loop, whatever you are writing, it should be equal to 0. So V minus this, it should be equal to 0. This is what he is saying. And logically it should be correct too, because see, because what force is over here? Obviously electrostatic force. Electrostatic force is here, and electrostatic force is a conservative force. If you are coming to the same position again, obviously potential difference should be 0. उसमें कौन सी बड़ी बात है? If we are coming to A like VA again, तो obviously potential difference should be 0. Correct? उतना चढ़ा उतना ही उतरा. तो what is the difference of height? Nothing. Correct? Similarly, you are getting it, correct? If we are coming to the same point, the potential difference will be 0. This is what he is saying. But this whole thing, why we are studying this, if it is logical, and we have already discussed in electrostatics, because using this law, correct, we can calculate very complex problems. We can calculate, this is a very simple circuit, but in exam, they will ask you a complex circuit where they will ask you, okay, in this circuit, what is I? In that circuit, what is I? So you have to calculate 3 or 4 current in a very complex circuit. So this law, it will help you out, okay? With this simple law, that is Ohm's law, V equals to IR, we are not able to calculate it entirely, and you will be confused a lot, and basically you cannot do it using V equals to IR, okay? Just using V equals to IR, okay? So by using this loop law, okay, it's very easy to calculate all those types of questions. I hope you are getting it, right? Check it. Now, okay. Now the next topic is what? Your electromotive force. Do not worry about this thing. Please firstly listen what I am trying to say. So whenever you are going to market, okay, you buy a battery. So on that cell or battery, something is written, let's say 3 volt. If 3 volt is written on that battery, okay, so that is known as EMF, electromotive force. Sir, why force is written on the battery? Because in the olden days, the whole concept was not clear, whether it is a potential difference, whether it is a force. So, but we are using the same, wordings. We are using the same name, generation to generation. Okay, so that's why we are using electromotive force. Please do not get confused with electromotive force. Electromotive force is nothing but a potential difference only. Okay, so basically, whatever is written on the battery, let's say if it is written as 3 volt. If it is written as 3 volt, then 3 volt is the electromotive force. It is what? Electromotive force. And now let's say you are connecting this battery to a voltmeter. Voltmeter is a device, we will learn in the next chapter. Voltmeter is a device which kind of calculates the potential difference. Okay, when you are attaching the voltmeter, you are getting just how much? Let's say you are getting 2.5 volt potential difference. It means what? The potential difference across the battery is 2.5, but its EMF is 3 volt. So you will say, sir, so where is this drop of 0.5 volt is coming from? Because every cell is made up of electrolyte. If you have played, if you have lived your childhood properly, then you might have cut the cell. If you have cut the cell, okay, there is some black thing or some liquidy thing is there inside the cell. Are you getting it? Some liquidy cell or liquidy substance is inside the cell. That liquidy substance is known as what? Your electrolyte. So there are dry cells, there are battery wala cells. Are you getting it? In a battery, there is the whole electrolyte is liquid. Okay? In your cell, proper cell that you use in your remote, over there it is in a semi-solid form. Okay? Something black rod is there, okay, but a molten form is also there. Okay? Semi-solid. But when we are talking about dry cell, the entire thing is what? The dry thing. Okay? The electrolyte is dry. Okay? So basically, because of this electrolyte, okay, some resistance comes internally inside the battery. So we call this resistance as internal resistance. Again, one more time. See, we are going to market buying a battery of 3 volt, that is known as EMF. Okay, but when we are connecting this whole battery with the voltmeter, the potential difference is coming as what? 2.5. So 0.5 drop in potential difference, went where? So basically, this 0.5 decrease in potential difference, it is coming due to the internal resistance. Okay, the internal resistance of the battery. The battery is not allowing properly the flow of the charges. It is creating the resistance internally. Something that you will understand it better in electrochemistry of grade 12 only. In chemistry, there is a chapter which is known as electrochemistry. Over there, you just learn about cell. How do we make cell? Okay, if we want to make cell of, let's say, 10 volt, if we want to make a cell of 100 volt, how should we make it? Okay, so that's the science over there. What electrolyte with different, right? Like all different electrolytes, you will play over there. So But right now I'm just telling you कि in electrolyte when charge passes from one electrode to another electrode, there is a resistance created by the electrolyte itself. So that is known as your internal resistance. Because of this internal resistance, potential will drop by, yes, IR, okay, or negative IR. You are getting it, right? Whenever there is a resistance, potential difference will drop by IR. Okay. Now we can basically go through this. So every cell and battery has internal resistance R. You will understand it better in chemistry's chapter, that is known as electrochemistry. No problem. Now over here, whenever there is a battery given, okay, so they will mention this. They will mention this small r just near to the battery. Small r. Small r. Small r. Okay, just near to the battery. This small r is nothing but internal resistance. Internal resistance. Internal resistance. Okay. So basically, they just represent it. Okay, this is not the resistance that you can visualize, that you connect it along the circuit. Okay, some of the resistance that if we are going to the lab, we will see okay, this is the resistance which is connected to the circuit. But this resistance is not visible directly to your eyes. It is the resistance which is already there inside the battery or the cell. Okay, so that's why it is known as internal resistance, and basically it is just denoted just near to the, it is marked just near to the battery. Okay, so very important thing. Okay, when we will be doing the lecture of J means NEET and advanced, over there I will tell you how we are getting all these values. But right now, please memorize them. You know, over there too, it will help you a lot if you are memorizing this. So first thing, if battery is discharging, what do we mean by discharging? If current is flowing through the battery, obviously after some time the cell will run out. Okay, so you will say कि हाँ खत्म हो गया, अब मुझे नया cell चाहिए. Okay, my toy is not working. So basically the cell has run out. It means what? The current was flowing through it. So this is known as discharging. So during discharging, potential difference, remember this, potential difference across the battery is V equals to E minus IR, where E is what? EMF of the battery. When battery is discharging or current is coming out through the battery, then the potential difference across the battery is E minus IR. Please remember this. E is what? E is what? Your EMF. Okay. So potential difference, when I am attaching a voltmeter over here, that's why I was getting a drop of negative IR. Are you getting it? Correct? The same story. This was 3, this was 2.5. So why this drop was coming? Because of this internal resistance. Okay. So please memorize like this. Potential difference when battery is discharging is E minus IR. But when battery is charging, then the potential will be what? Across the battery, it will be E plus IR. Something that you should know. Okay? It will help you a lot in competitive exams. Check. Please look carefully. Do you have any doubt? If you have any doubt, we will solve. Fine. Done, Janta? Okay. Now over here, V is what? The potential difference across the battery. R is what? Internal resistance. Already discussed. Okay. Now the same story in the box. Let's say we buy a cell of voltage of 3 volt from market. This is known as EMF of 3 volt. Okay. But by applying wire, we are getting a 2.5 volt potential difference over here. Okay. So this is potential difference, that is 2.5, and 3 was what? Your EMF. Okay. I hope you are getting it. Chalo. The internal resistance occurs due to the resistance created by the electrolyte. Okay, something that we will learn in electrochemistry. Okay. Then with that, चलो आ जाओ. अब ये छोटा सा टॉपिक है, like there is very small topic. cells, cells in series and parallel. Cells in series and parallel. Okay. So basically, instead of attaching just one battery, if we are attaching a series of batteries, as you do in the toy, correct? So few of the AC remote, it requires 2 cells. Your any car, remote car, it might require 4 cells. Correct? Are you getting it? So few of the other stuff, it can require 10 cells. So over there, you need not just one cell, you need a series of cells. Correct? Okay. So first is your cells in series. Okay? Check. So basically, we just want to calculate if this is a battery 1, E1, and internal resistance is R1. Okay? This is battery 2. Internal resistance, like EMF is E2, internal resistance R2. Okay? We want to see a battery, we want to convert this whole thing into a battery whose EMF is E equivalent and whose R is R equivalent. Okay? So by looking at the picture, you might get it, yes, what's the answer, but let's see. Now calculate it. Let's say current I is flowing over here. Okay? Current I is flowing. Okay? Now there are points. Let's say 1, 2, and 3. Okay? So A point, B point, and C point. Okay? So now we just learned across the battery what is the potential difference. Correct? Okay. So can we write VA minus VC equals to, this is discharge, E minus IR, or E1 minus IR1. Correct? E1 minus IR1. Very good. Okay. Now on the same ground, so let's call it as equation 1. On the same ground, can we write equation 2, which is what? We can write over here VC over here. What is the higher potential? VC. Okay. So VC minus VB equals to your what? E2 minus IR. Correct? Add them both. So if you are adding them, so what will cancel out? VC, it will cancel out. Correct? Cancel it. By adding equation 1 and 2, we get VA minus VC equals to E1 minus IR1, VC minus VB equals to E2 minus IR. Now, if we are adding them, VC getting cancelled out. Okay, so VA minus VB equals to E1 plus E2 minus R, R1 plus R. Correct? Okay. So from here, if we are writing this whole equation, this equation as E minus E equivalent minus I R equivalent. Okay? So it will be written as E1 plus E2 minus R1 plus R. So from here it's very clear picture, correct? That E equivalent, so by comparing we can get this masala is equals to this masala. This masala equals to this masala. So we can write E equivalent equals to E1 plus E2 and R equivalent equals to R1 plus R. ठीक है? So basically, the moral of the story is this: if you have 2 or 3 cells in series, ठीक है? So E equivalent will be E1 plus E2 plus E3 and so on. R equivalent will be R1 plus R2 plus R3 and so on. ठीक है? Please look over here. Look the entire thing. There were 2 cells like this. We want a cell. We want the net EMF output due to the cells, and we want the net internal resistance. Okay? So by using this, by using the simpler, charging discharging thing. So discharging, we know potential difference across this battery will be E1 minus IR1. Over here it will be E2 minus IR2. Okay? So just adding the equation, we are getting VA minus VB, which we can write it as E equivalent minus I equivalent. Right? I mean R. Okay. We are getting this. Okay. So from here we are getting this. After this step, we are just comparing. I hope you are getting it. Here, check. So the moral of the story is this. This whole derivation is very important. You know, guys? So first thing, if you have cell you are getting it, right? E1 R3, E2 R2, E3 R3, E4 R3. Then it will be, we just want this picture. E equivalent R equivalent. So E equivalent will be nothing but R, sorry, E1 plus E2 plus E3 and so on. Okay? And similarly, R equivalent will be R1 plus R2 and so on. Okay? Okay. Now, what if they are the batteries over here, they are reversed, like the sign between the battery is changed. Okay, so now let's say like over here, if this is E1, this is R1, now they are kept in a very different direction. Okay, they are not syncing each other, right? This is helping this, but this is trying to destroy, right? Okay, so over here, E equivalent will be E1 minus E2. Over here, I am assuming that E1 is greater than E2. Okay, so this is my assumption. But R equivalent, guys, now listen carefully. Resistance, it does not depend on sign, correct? So it will be just, we will be just adding the resistance, correct? So R equivalent, it will be just R plus R. So resistance will be just same as that, and over here, if we are reversing the polarity, correct, the sign will reverse, correct? I will go. Check. Can you write it over here so that you might not get confused? So when polarity R polarity R reverse. Okay. Okay. So this will be the case. I'm closing. Okay. So this was the case in series, very easy to understand, right? And logically, without even doing it, you can your heart might be saying the same thing. That this should be the answer. I hope you right? Okay. But for parallel, it's a very tricky thing. So for parallel thing, whatever I'm doing over here, please do it at least 5 times. Otherwise, you won't understand it. Okay? The formula, you know, it's not welcoming much. Okay? When we are going to discuss about parallel thing, when cells are in parallel, the formula is you won't like it. But sometimes we have to do the things that we do not like. Okay? As you are doing that yes, studying by online lectures. Now, done? Check. Now, let's write down the heading. Cells. Cells in parallel combination. Okay. Over here we will use sigma, that is nothing but the summation of something. Okay. So when we are writing sigma, let's say when we are writing sigma 1 upon r, just telling you, sigma 1 upon r, it is nothing but 1 upon r1 plus 1 upon r2 plus 1 upon r3 and so on. Okay? When we are writing sigma ei upon ri divided by sigma 1 upon ri, so it means what? E1 upon r1 divided 1 upon r2 plus E2 upon r2 divided 1 upon r2 and so on. I hope you are getting it.
आपका दोस्त आया था तो आपको दो आया ना
हाँ
एक किधर है
चलिए हाँ
आप 6 o'clock तक है
हाँ okay so we can write like this. I'm getting it. Okay, check. So just the extra stuff so that okay, check. Now let's do our derivation. Okay, cells in parallel combination. So the diagram will be like this. Let's read diagram. Okay, so the whole circuit is like this, that you are connecting and batteries in parallel, and over there you are also connecting a resistor. Okay? This resistor might be anything, like your motor, right? Let's imagine that you need to run a motor, a small, in a toy there is a motor. So you want to run that motor. So it could be that motor, it could be a bulb, and over here you are doing what? Over here you are connecting the cells in parallel combination. So basically we want this. We want this. That is, what is R equivalent, what is E equivalent, and which is connected to this R. Okay? So we want to calculate E equivalent and R equivalent. I hope this whole picture is clear. Correct? These all are in parallel combination and we want to get this. Let's do it. So one more time, I'm just making a very small circle. Okay, so this is the circuit. Okay, now we can use Kirchhoff's law in the outermost circuit. Okay, so using loop law, using loop law, okay, or using Kirchhoff's loop law. Using Kirchhoff's loop law. Okay, check. So if we are taking this circuit, अच्छे से देखना, we are taking this one, the outer one. Okay, check. So how can we write it? अच्छे से देख. E1, when we are starting from here, E1 minus IR1, E1 minus, we should write I, okay, enter I, E1 minus I, R, over here what current is flowing? R, and over here what current is flowing? I1, I2, Rn, okay? But we all know the summation of I1, I2 and In, it should be In. So I1 plus I2 and dot till In, it should be In. Okay. So through resistor I, through resistor capital R, what current is flowing? R, right? So E1 minus IR. Now we are reaching to this internal resistance R1. So over here, what current is flowing? I1. So we should write like minus I1 R, okay, equals to 0. Algebraic sum should equals to 0. Starting from here, if you are coming again here, it should be 0. Correct? Okay. Similarly, on the same ground, can we write like this? Okay. Now we are doing the same thing in this circuit. Are we getting it? Okay. So same thing over here, minus I2 R2 equals to 0. Correct? Okay. And so on. And so on. Correct? Till where En IR minus Rn Rn equals to 0. Okay. Now if we are adding them all, what will come? अच्छे से देखो. Over here it will be sigma. E1, E2, E3 and everything, it will be sigma EI. Yes or no? Correct? This symbol is for what? Summation. Sigma EI. Correct? Okay. Now, over here, if we are adding all of them, then 1, 2, 3, 4, how many IR will come? NIR minus NIR. Correct? Okay. From here, what will come? देखो अच्छे से. Over here, what will come? If we are adding all I1, I2, R3, correct? Over here, so it is nothing but sigma I R I, correct? Okay, equals to 0. Huh? अच्छा, इसमें अपन एक चीज करते हैं, एक थोड़ा सा स्मार्टली प्ले कर सकते हैं, वरना प्रॉब्लम हो जाए. ठीक है? तो हम इसको ऐसा लिख लेंगे, दिस होल इक्वेशन इफ वी आर डिवाइडिंग विद R1, ओवर हियर वी आर डिवाइडिंग विद R1, ओवर हियर वी आर डिवाइडिंग विद R2, क्योंकि लास्ट में प्रॉब्लम हो गया इसलिए. सो दिस इक्वेशन वी आर डिवाइडिंग विद R1, तो क्या आ जाएगा बताओ? E1 अपॉन R1, R1, okay, equals to 0. Over here we are dividing this equation with R2, correct? Correct? Okay. Over here we will divide it this equation with Rn equals 0. अब when we are adding all of this I1, I2, I3, I4 and In, it will become what? It will become just I. तो यहाँ से काम है, वरना over there we were getting stuck, है ना? I. Okay. Now from here we can write sigma EI upon RI. देख, sigma EI upon RI. Over here what we write? Minus sigma minus I will come outside, okay, it will be sigma, even R will come outside, even R will come outside, right? R sigma 1 upon R, correct? Okay, and this thing over here, it will become what? Just R. This whole thing will become just R equals to 0. Okay, चलिए, तो now we will take I as common. Okay, देखते हैं क्या रहता है. So can we write sigma EI upon RI minus I if we are taking it as common. So inside it will be R sigma one upon RI, correct? Minus I equals 0. Okay. Now from here we are taking R to that side. तो क्या देंगे? Sigma EI upon RI equals to R. देखिए अच्छे से 1 plus R 1 upon sigma R, right? So you can write sigma 1 upon R, right? Okay. Now this will come over here. Then sigma EI upon RI divided by 1 plus R sigma 1 upon RI equals to R. Okay? Chalo. Now let's divide this whole thing with 1 upon RI. तो कैसा है? हाँ, जस्ट राइटिंग इट ओवर हियर. Okay, I'm just writing it over here so that you can understand it better. We are dividing by sigma 1 upon r. तो आंसर देखना कैसा आता है. सिग्मा ई आर अपॉन आर है, ठीक है. न्यूमरेटर डिनोमिनेटर इज डिवाइडेड बाय 1 अपॉन आर, डिवाइडेड बाय सिग्मा 1 अपॉन आर है, ओके, डिवाइडेड बाय 1 अपॉन आर. तो आंसर विल बी 1 divided by 1 upon sigma 1 upon Ri plus R. Yes. Equals to R. ठीक है, तो इसका मतलब समझते हैं. ओके, this thing over here, because if this is R, this should have dimension of R, correct? So it is like V by R, current equals to V by R, and this thing over here is nothing but E equivalent, and over here this is your what? बोलो, R equivalent. ठीक है? I hope you are getting it. One more time. ठीक है? We are assuming like this, correct? We are writing using the Kirchhoff's equation in every loop law, in every case, okay, in every loop, E1, then E2, then En, okay, we are writing like this. Now adding them all, so E1 upon R1 and all this, right? So when we are adding it, sigma will come. When we are adding it, sigma will come. When we are adding it, sigma will come. Smartly, we are dividing with R1 over here R2, R3. Why? Because when we are adding this thing, only I will come. I1 plus I2 plus I3 till In is R, right? So this will come. Now taking I common from here and playing with it, okay? So, correct? Taking I common from here and playing with it. So this masala over here is E equivalent, and over here this masala over here is R equivalent, okay? Check. So E equivalent is nothing but sigma EI upon RI divided by sigma 1 upon RI, ठीक है? And R equivalent equals 1 upon 1 over sigma R. Okay? This is nothing but R1 plus R2 and R3 only. But if you are remembering like this, it will be easier for you. Okay? Check. So now start points. Let's say n identical cells are there in parallel combination. Okay. So E equivalent, it will be written as E R. E I will be what? E only, and R I will be, you know, the EMF of each cell will be same E, and R internal resistance of each cell, it will be R only, correct? So can we write E1 E by R plus E by R plus E by R, how many times? N times. So instead of writing this, can we write just N times E by R, correct? Divided by 1 upon R. So 1 upon R plus 1 upon R plus 1 upon R plus 1 upon R, can we write what? N by R, बोलिए, can we write N by R? So are you getting it? That N, they are cancelling each other, okay? R, they are cancelling each other. Final answer is nothing but E1, okay? So E equivalent, when n identical cells are there in parallel combination, E will be E will be, okay? Check. But R equivalent will be, बोलो, आपका क्या आ जाएगा? 1 upon this thing. So it will be 1 upon n by R or R by n. same thing as parallel. So remember it like this, that this is the same thing as parallel combination. Same as parallel combination. 1 upon R equals 1 upon R1, 1 upon R2, and so on. If someone is asking you in this where the cells are connected in parallel combination, okay, so what will be the net resistance? Okay, so you can calculate like this. This is it. So that's why I'm saying, please do this derivation at least 5 times. Otherwise, you won't get it. Huh? Please write it down at least 5 times. Otherwise, we will have great problem. Okay. Check. Done. Done. Okay. Chalo. Now coming to the last topic of this entire chapter, that is known as Wheatstone bridge. Wheatstone bridge. Very easy concept, very easy to understand. Okay. And the diagram, I promise you that you will love from this point. Okay. In first look, it might look difficult, but when you will understand it, you want that your desire will be this, that every question should be a Wheatstone bridge. Okay, चलो अच्छे से देखो. Over here, very symmetric kind of thing. Over here, they are resistance. Correct? They are connected to certain battery or a cell like this, and now this whole thing is connected with a galvanometer, and you have one more resistance over here. Okay? Let's name these resistance as R1, R2, R2 third, कोई फर्क नहीं पड़ता, R3, R4, R1, R2, R3, R4. Okay. So now, can we say this, everyone? Let's say this is the case for Wheatstone. This is the case for Wheatstone. Okay. So now, the guy over there, he says that in a balanced Wheatstone bridge, there will be no current flowing through the galvanometer. Okay. This is the fundamental. In balanced Wheatstone bridge, the current through in balanced Wheatstone bridge, no current flows through R5 through galvanometer, you can say. Or R5. Okay. This is the case that galvanometer will show no deflection. Okay. So galvanometer is a device, when current flows through it, it will tilt towards the direction of the current. You would have seen this in the lab. Okay. So when current is flowing through the galvanometer like this, if this is the pointer, okay, current is flowing in this direction, then galvanometer is pointer, it will deflect in this direction. If current is flowing in this direction, galvanometer will, the pointer will deflect in this direction. I hope you are getting it, right? So in a balanced Wheatstone bridge, no current flows through the galvanometer. So it means what? There will be no deflection. There will be no deflection in galvanometer. Okay, so now you might wonder, how can we achieve this? Okay, so the only one way to achieve this is this, that is, if the potential over here, and over here, if the potential becomes same, if potential becomes same, potential difference is 0, current will be 0. Okay, that's the only case, that's the only chance we have to prove that this is the balanced Wheatstone bridge. Okay, so now what we are doing, again quickly make it. So the only way it could happen, let's say, if potential is x over here, potential over here, it should be x. Okay, let's say if the potential of this battery is V, so potential over here we can write as 0 at this point. At this point potential will be V. Okay, चलेगा? Okay, now let's say current in this circuit is I1, and in this branch is I2. In this branch it is I3, in this branch it is I4. Okay, check. So can we say, please look into this branch. This branch is not connected to this. If the current over here is 0, obviously whatever current is flowing from this branch, it should go into this branch. Or we can say I1 equals to I2 and I3 equals to I4. Yes or no? Okay. I1 equals to I2. I1 equals to I2, correct? How can we write current? Current is nothing but potential difference upon resistance. So what is the potential difference for R1? It is V minus X upon R1. Difference of the potential across the resistor R, correct? V minus X upon R1 equals to what is the potential difference across R2? X minus 0. X minus 0 upon R2, correct? Okay, so from here we are getting V minus X equals to, V minus X upon X minus 0 equals to R1 upon R2. Now similarly, can we write I3 equals to I4, because this whole thing is, is not connected to anything. Whatever current is coming in this branch I3, I4 should be, correct? The same current should flow through this branch. It means what? I3 should be equals to I4, correct? I3 equals to I4. I3 आप कैसे लिखेंगे बताइए? V minus X potential difference upon resistance. What is the resistance over here? R. I4 over here. What is the potential difference? X minus 0 divided by your R4. Yes or no? So from here, can we get V minus X upon X minus 0 equals to R3 upon R4. Now you can see clearly, you have two equations and two. Not equation, what happened? You have two equations from here, from equation 1 and 2. From 1 and 2, can we get R1 equals to R2 upon R2 equals to R3 upon R4. This is the condition for balanced Wheatstone bridge. Okay? So this upon this equals to this upon this, then yes, it is balanced. Okay? So condition for balanced carefully, there was a Wheatstone bridge like this, correct? Okay, so we did this, that we say a balanced Wheatstone bridge, it means no current flow through galvanometer, okay, galvanometer's pointer showing no deflection, okay. So how can it happen? It can only happen if the potential over here and over here becoming same. If potential over here and over here is same, it means what? Potential difference is zero. Current through this green wire is zero, correct? Okay. So we did this x and x. So potential, if V is the voltage of the battery, can we say V is over here, 0 is over here. Potential difference across R1, it will be V minus x. So if we want to write current, let's say current flow, I1 is flowing through it, same current should flow through R2. So I1 equals to R2, potential difference across R1, we can clearly see V minus x upon R1. Current is nothing but potential difference upon resistance equals to I2. I2 is x minus 0 divided by R2. Correct? Same thing, we are getting the equation V minus x equals to x minus 0. I know x minus 0 is x only, but t. R3, I3, I4, correct? I3 should equal to R4 because none of the current is flowing through this green wire. So can we write V minus x upon R3 equals to x minus 0 upon R4, correct? Same thing. Now, this whole kachra is same. LHS, LHS is same. So RHS, RHS should be same. So from here we are getting the condition for balanced Wheatstone bridge. R1 upon R2 equals to R3 upon R4. Or whenever the question will come, check this, that if this upon this equals to this upon this, then obviously this whole thing will be, this R5, you can neglect it. None of the current is flowing through it, so you can neglect it. Pata hai kya? So by doing this, the whole question will be really easy. How? Because now R1, R2 are in series, R3, R4 are in series, and the whole combination is in parallel. So that's why your desire will be this, that every question, if it is coming in this format, if picture is like this, you will desire this, that to God, that if R1 upon R2 equals to R3 upon R4, then it is a balanced Wheatstone bridge, and it is very easy to solve Wheatstone bridge. Why? Because R1, R2 will be in series, R3, R4 will be in series. So upper branch resistance is R1 plus R2, over here R3 plus R4. Now these two branches will be parallel. When we do like this, key R1, R2, like that. So you might think, okay, now R1 plus R2 and R3 plus R4 in parallel combination. It looks like a big number, but if I'm just giving you a number, 1, 2, 4, 2, okay? Now 1, 2 is a 3, 4, 2 is 6, 3 and 6 in parallel, answer is 2. Are you getting it? So that easy. Orally you can solve it, okay? So that's why Wheatstone bridge and balanced Wheatstone bridge is very easy to understand. It is based on what? A very simple logic, that potential difference over here, it should be 0, but potential at these two points it should be same. Okay. So with this whole Wheatstone bridge, guys, we have completed our chapter, that is current electricity for boards. Chalega. Okay, so from next lecture, we will start with moving charges and mechanism. Thank you so much. Have a nice day.